The universe is vast beyond ordinary intuition. It stretches outward in every direction, filled with galaxies that each contain billions of stars, and around those stars, countless worlds. From the moment humanity learned that the Milky Way is not unique, that it is only one galaxy among hundreds of billions, a quiet expectation formed. Somewhere among all that space and time, there should be others. Other minds, other civilizations, other worlds that once looked up at their own night skies and asked the same question. Yet when we listen, when we search, when we stretch our instruments as far as physics allows, we find nothing. No greetings, no signals, no signs of intelligence at all, only silence. This silence is not empty. It is dense. It presses against every observation we make. Radio telescopes sweep the sky night after night, filtering through the natural hum of the universe, the steady whisper of hydrogen clouds, distant neutron stars, the faint afterglow of the Big Bang itself. Among all of this, scientists search for one thing that does not belong, a signal shaped by intention. A pattern too precise, too deliberate to be natural. But decade after decade, nothing emerges. The universe does not answer. At first, this absence seemed temporary. Early astronomers assumed that contact was only a matter of time. The galaxy is old. Our planet is young. Surely someone else would have spoken already. But as instruments improved and searches widened, optimism gave way to unease. The silence endured. Not just silence in one direction or one frequency, but silence everywhere. The kind of silence that feels deliberate. The kind that suggests restraint rather than emptiness. This mystery has a name. It begins with a simple question asked in the middle of the 20th century by the physicist Enrico Fermi. During a casual conversation, he posed a problem that still unsettles science today. If the universe is so large, so old, and so full of stars, then where is everyone? The logic behind the question is straightforward. The Milky Way alone is more than 13 billion years old. Our own planet formed roughly 4.5 billion years ago, which means that for billions of years before Earth existed, stars were already forming planets. Entire civilizations could have risen and fallen long before the sun ignited. Even if intelligent life were rare, even if it emerged on only a tiny fraction of worlds, there has been more than enough time for at least one civilization to spread beyond its home system. Given modest assumptions about technology, a single spacefaring species could traverse the galaxy in a few million years, a blink compared to cosmic time. And yet, there is no evidence that anyone ever did. This contradiction between high probability and zero observation is known as the Fermi Paradox. It is not a failure of imagination. It is a failure of expectation. Everything we understand about biology, chemistry, and planetary formation suggests that life should not be unique to Earth. Modern astronomy has confirmed this intuition. Thousands of exoplanets have been discovered, many of them rocky, many of them orbiting within regions where liquid water could exist. Some have atmospheres. Some show complex chemistry. The raw ingredients of life appear to be common. And still, the universe remains quiet. To explain this, scientists have proposed many solutions. Some argue that life itself is incredibly rare, that the emergence of biology is an almost impossible accident. Others suggest that intelligent species tend to destroy themselves before they can reach the stars, undone by war, environmental collapse, or uncontrollable technology. This idea leads to what is known as the Great Filter, a stage in development that almost no civilization survives. The filter could lie behind us, meaning we are extraordinarily lucky. Or it could lie ahead, meaning silence is a warning rather than a mystery. But among all proposed explanations, one stands apart for how cold, how logical, and how unsettling it is. It does not rely on accidents or improbabilities. It assumes that intelligence is common, and that survival, not curiosity, is the dominant force shaping the galaxy. This idea is known as the dark forest theory. The name comes from an image. Imagine the universe as a vast forest at night. Every star is a tree. Every planet is a shadowed clearing. Somewhere among them move hunters, intelligent civilizations that have learned to survive. In this forest, visibility is danger. Every sound risks revealing your position. Every light risks attracting something that cannot be reasoned with. In such an environment, the safest action is silence. Not because others are hostile, but because their intentions can never be known. The dark forest theory rests on a few simple assumptions. First, every civilization wants to survive. Second, no civilization can ever be certain of another's intentions. Third, the universe contains finite resources, and the cost of being wrong about another civilization's motives is extinction. From these assumptions, a brutal conclusion follows. The safest response to discovering another civilization is not communication, but elimination. Not out of hatred, but out of logic. In a universe governed by physics, there is no reliable way to negotiate across light years. Messages take decades, centuries, or millennia to arrive. Any reply would come too late to correct a misunderstanding. Trust cannot form when time itself prevents dialogue. From the moment one civilization detects another, it must assume the worst. Silence becomes wisdom. Exposure becomes fatal. This logic transforms the silence of the universe into something far more disturbing than emptiness. The absence of signals may not mean that no one is out there. It may mean that everyone who survived learned the same lesson. Do not speak. Do not shine. Do not be seen. Humanity itself has already begun to understand this without fully realizing it. For more than a century, Earth has been leaking radio waves into space. Every broadcast, every radar pulse, every early television signal has raced outward at the speed of light, forming an expanding shell of electromagnetic noise around our planet. To any observer within that sphere, Earth would appear different. Not bright, not loud, but patterned, artificial, alive. That radio bubble now extends roughly 100 light-years in every direction. Within it are thousands of stars, many with planets of their own. If any advanced civilization exists nearby, it could already know we are here. It would not see our present. It would see our past. The earliest layers of that bubble carry fragments of our first broadcasts, crude signals from a young technological species unaware that it was announcing itself to the cosmos. And yet, something interesting has happened. As our technology advanced, our signals became quieter. Modern communication relies on cables, satellites, tight beams, and low-power transmissions. The wasteful radio noise of early broadcasting is fading. Without intending to, humanity is learning how to disappear. Our planet is becoming harder to detect from afar. Not because we chose to hide, but because efficiency demanded it. If the dark forest theory is correct, this pattern is universal. Young civilizations shine briefly, loud and naive. Older ones grow cautious. They minimize emissions. They bury infrastructure. They suppress any signal that could give them away. The most advanced civilizations would not build galaxy-spanning empires or glowing megastructures. They would look from the outside, exactly like lifeless star systems. This is why the sky appears empty. Not because it is uninhabited, but because the inhabitants learned how to remain invisible. The implications of this idea are profound. It suggests that the universe may be full of watchers. Civilizations that observe quietly, cataloging new life as it arises, never intervening, never responding. It suggests that the first civilization to break the silence does not become a neighbor. It becomes a target. The dark forest theory does not claim that the universe is cruel. It claims that the universe is indifferent, and that intelligence, when combined with fear and uncertainty, naturally converges on caution. No evil intent is required, only the desire to survive. As humanity continues to listen, continues to search, continues to wonder why no one answers, this theory offers a chilling possibility. The silence we hear may not be the absence of life. It may be the sound of restraint, the sound of civilizations older and wiser than ours choosing not to speak. And if that is true, then the most dangerous moment in our history may not lie in the future, but in the past. The moment we first spoke into the dark, unaware that the forest was already full. The question raised by the Fermi Paradox does not weaken with time. It grows sharper. Every improvement in astronomy, every new catalogue of planets, every refinement of stellar models tightens the contradiction. The more we learn about how common planets are, how early they form, and how long stable environments can persist, the more difficult it becomes to explain the absence of visible intelligence. The galaxy has had billions of years to fill itself with life. Even slow, cautious expansion would have left traces. And yet, nothing appears. To understand why this is so disturbing, it helps to look at the numbers without romance. The Milky Way contains hundreds of billions of stars. A large fraction of those stars are older than the Sun. Many host planets. A smaller fraction host rocky planets in stable orbits where liquid water could exist. Even if intelligent life arises on only one planet out of a million, the galaxy should still contain thousands of technological civilizations across its history. Time alone almost guarantees it. A civilization does not need faster-than-light travel or exotic physics to spread. Even probes moving at a small fraction of light speed, stopping occasionally to replicate and continue, could traverse the entire galaxy in a few million years. Compared to cosmic timescales, that is nothing. This is what makes the silence so heavy. It is not just that we have not been visited. It is that we see no indirect evidence at all. No artificial signals. No large-scale energy use. No stellar engineering. No debris. No unmistakable fingerprints of intelligence acting on a galactic scale. If even one civilization had expanded aggressively at any point in the last few billion years, its influence should still be visible. Stars do not forget. Orbits preserve history. Yet the sky looks natural, untouched, ancient. One possible answer is that civilizations rarely survive long enough to expand. This is where the idea of the Great Filter becomes unavoidable. The Great Filter is not a single event, but a category. It represents one or more steps in the progression from simple matter to galaxy, spanning intelligence that are so difficult or so dangerous that almost nothing gets past them. The filter could be early. It could be the origin of life itself. It could be the jump from simple cells to complex organisms. It could be the emergence of intelligence. If the filter is behind us, then humanity is exceptional. A rare accident in an otherwise silent universe. But there is another possibility, and it is far more unsettling. The filter may lie ahead. It may be triggered not by biology, but by success, by technology, by the moment a civilization becomes capable enough to destroy itself or to draw the attention of something else. In this view, intelligence is not a stable endpoint. It is a brief phase. Civilizations rise, make noise, and vanish before they can leave a lasting mark on the galaxy. The dark forest theory fits naturally into this framework, but it shifts the cause. It does not require civilizations to self-destruct by accident. It only requires them to behave rationally in a hostile informational environment. In a universe where detection is asymmetrical and the cost of error is extinction, survival favors silence. Any civilization that broadcasts loudly announces its location. Any civilization that announces its location invites scrutiny. And scrutiny, in a dark forest, is dangerous. Visibility is not neutral. It is exposure. Every technological advance carries with it an increase in detectability. Energy use produces waste heat. Communication produces radiation. Industry alters atmospheric chemistry. Even the peaceful civilization cannot hide its activity indefinitely unless it deliberately chooses to. From a distance, a living world and a technological world look very different. Life leaves patterns. Technology amplifies them. Once a civilization becomes visible, it enters a dangerous phase. It may be observed by others that are older, faster, or simply more cautious. Those observers do not need to be hostile by nature. They only need to understand one thing. If another civilization exists, it has the potential to become a threat in the future. And because communication across interstellar distances is slow and unreliable, waiting to see what that civilization becomes is a risk. A risk that may not be survivable. This is where the logic hardens. In a dark forest, there is no safe way to reveal yourself. There is no way to prove peaceful intent. Any signal you send can be misinterpreted. Any delay in response can be fatal. From the moment you are detected, the clock begins to run, but you cannot see it. You cannot know who has seen you or what they have decided. Silence is the only strategy that minimizes risk. The theory does not require constant violence. In fact, it predicts the opposite. A galaxy shaped by this logic would be quiet most of the time. Not because nothing happens, but because the consequences of being noticed are so severe that civilizations learn to suppress activity before it reaches that point. Those that fail to do so do not leave descendants. They become brief anomalies in an otherwise stable silence. From this perspective, the absence of signals is not surprising. It is expected. The sky does not glow with intelligence because intelligence that glows does not last. The civilizations that remain are the ones that learned how to dim themselves until they are indistinguishable from nature. This also reframes humanity's situation. Our early radio transmissions were not intentional messages to the stars. They were accidents, side effects of inefficient technology. For a short window in our history, Earth was loud. We broadcast without thinking about who might be listening. That window is now closing. As communication becomes more efficient, more compressed, more directional, our planetary signature is shrinking. We are becoming quieter without ever deciding to. If the dark forest logic governs the galaxy, then this is not coincidence. It is convergence. Young civilizations all pass through a noisy phase. Most do not survive it. Those that do learn restraint. They turn inward. They limit exposure. They choose longevity over curiosity. This raises a final, uncomfortable implication. The silence we hear may not be the beginning of the story. It may be the end of countless others. A galaxy once filled with experiments in intelligence, now dominated by the few that learned the same lesson. Survival does not belong to the loudest or the fastest. It belongs to the quietest. The forest is dark not because there are no hunters, but because every hunter knows that the first one to make a sound may be the first one to die. The idea that survival favors silence becomes even more convincing when the limits of communication are examined closely. On Earth, misunderstanding is common even when words travel instantly and cultures share biology, history, and environment. Across interstellar distances, misunderstanding is guaranteed. Light itself enforces delay. A message sent to the nearest star system takes years to arrive. A reply takes years more. Any exchange is stretched across decades at minimum, centuries in most cases, and millennia across much of the galaxy. There is no conversation, only a sequence of isolated declarations frozen in time. Because of this, intent cannot be clarified. A message cannot be corrected once it leaves its source. It carries the assumptions, values, and context of the civilization that sent it at that moment, and nothing else. By the time it is received, the sender may have changed or ceased to exist entirely. The receiver has no way of knowing whether the signal represents a peaceful culture, an expanding empire, a dying species, or a technological probe acting independently of its creators. In the absence of certainty, caution dominates. This is where the dark forest theory departs sharply from hopeful visions of interstellar diplomacy. It does not assume evil. It assumes ignorance. In a universe where the first strike is decisive and the cost of delay is extinction, ignorance alone is enough to justify preemptive action. A civilization does not need to hate another to eliminate it. It only needs to fear what that civilization might become. The physics makes this fear rational. Interstellar weapons do not require vast fleets or prolonged wars. A single object accelerated to a significant fraction of light speed carries enormous kinetic energy. Even a relatively small mass, if guided accurately, could sterilize a planet on impact. Directed energy systems, focused beams of radiation, could disrupt atmospheres or biospheres without ever revealing the attacker's location. These are not speculative fantasies. They are direct consequences of known physical laws. No exotic technology is required. Only time, energy, and patience. In such a universe, anonymity becomes power. The most dangerous civilizations are not the ones that announce themselves, but the ones that remain unseen. From this perspective, expansion is not conquest. It is camouflage, a civilization that spreads carefully, quietly, and selectively, could monitor vast regions of space without ever being detected. It could observe emerging worlds, assess their development, and decide whether they pose a future risk, all without making contact. This leads to a disturbing reinterpretation of observation itself. Silence does not imply disinterest. It may imply surveillance. A civilization that has survived long enough to understand the dark forest logic would have no incentive to reveal itself. Communication offers little benefit and enormous risk. Observation, on the other hand, offers information without exposure. The safest position is to listen, never to speak. Humanity already practices this instinctively. Our telescopes scan the skies, cataloging stars and planets, searching for anomalies. We observe without announcing ourselves directly. Our active messaging efforts have been limited and cautious, and even those have become controversial. The debate over whether to transmit intentional signals reflects an unspoken recognition of danger. The question is no longer whether others exist, but whether it is wise to let them know we do. If other civilizations have faced the same question, and if even a small fraction concluded that silence was safer, the galaxy would quickly become quiet. Not empty, but hidden. Over time, only civilizations that suppress their signatures would persist. Those that continued to broadcast would be removed, either by self-destruction, external action, or simple bad luck amplified by exposure. The result would be a stable equilibrium. A galaxy full of intelligence that looks, from the outside, completely natural. This equilibrium would be difficult to detect from within. Any civilization emerging inside it would see only stars and silence. It would conclude that life is rare or non-existent. It would search harder, build better instruments, and still find nothing. All the while, it might itself be observed by older, quieter watchers, assessing whether this new voice will learn to lower its volume in time. This is where the dark forest theory becomes most uncomfortable. It suggests that discovery is not symmetrical. One civilization may know about another long before the reverse is true. Detection does not imply contact. It implies awareness. A civilization that is detected may never know who has seen it or what decisions have already been made. This asymmetry makes signaling especially dangerous. A message does not invite dialogue. It reveals location. It provides data. It allows others to measure distance, energy use, technological maturity, and growth rate. Even a simple mathematical transmission carries more information than intended. It says that a civilization exists, that it can manipulate electromagnetic fields, that it has surplus energy, and that it has not yet learned to stay silent. From the dark forest perspective, that is enough. The theory also explains why large-scale astroengineering appears absent. Structures designed to harvest stellar energy on massive scales would be unmistakable. They would announce not only existence, but ambition. Any civilization capable of such construction would be visible across interstellar distances. In a galaxy governed by caution, such visibility would be a liability. The absence of these structures may not indicate a lack of capability, but a deliberate choice not to build anything that cannot be hidden. Over time, this logic produces a chilling pattern. Civilizations that value longevity over expansion remain small, quiet, and inward-focused. They may invest in virtual worlds, internal optimization, or slow biological and cultural evolution. Their presence leaves no obvious mark on the galaxy. Civilizations that prioritize outward growth, signaling, and visibility burn brightly for a short time and then vanish. Their absence becomes indistinguishable from the background. Seen this way, the Great Silence is not a puzzle waiting to be solved. It is a stable outcome, a natural result of intelligence constrained by physics and shaped by fear. The galaxy does not need to be hostile for this to occur. It only needs to be uncertain. Humanity now stands at an early point in this trajectory. We have begun to understand how visible we are. We have begun to debate whether visibility is wise. We have not yet decided what kind of civilization we intend to be. One that speaks, or one that listens. One that shines, or one that hides. The dark forest theory does not predict our future. It only frames the choice. In a universe where the cost of being wrong is extinction, silence may not be cowardice. It may be intelligence learning how to survive. As this logic is extended across longer timescales, another implication begins to emerge. Civilizations do not merely hide once. They must continue hiding forever. Survival in the dark forest is not a temporary strategy. It is a permanent condition. The moment a civilization relaxes its restraint, the moment it allows its emissions to rise above the cosmic background, it risks undoing millions or billions of years of caution. Silence must be maintained not for generations, but for epochs. This transforms the nature of progress itself. Technological advancement can no longer be measured by expansion, visibility, or influence. It must be measured by efficiency and restraint. The most advanced civilizations are not those that consume the most energy, but those that waste the least. Not those that reshape stars, but those that leave no trace at all. Progress becomes inward, not outward. Optimization replaces exploration. Stability replaces ambition. From this perspective, the absence of obvious alien megastructures becomes understandable. We often imagine advanced civilizations building enormous constructs around their stars, harvesting stellar energy on a vast scale. These structures would radically alter the light emitted by a star, making them easy to detect across interstellar distances. Yet surveys of the galaxy reveal no convincing evidence of such activity. Stars appear natural. Their light curves behave as expected. Their spectra show no clear signs of artificial manipulation. If intelligence is common and caution is necessary, this absence is not surprising. A civilization that understands the dark forest logic would recognize that such structures are invitations. They would declare not only existence, but capability. They would advertise energy use on a scale that implies technological maturity and long-term survival potential. In a universe where uncertainty equals danger, such advertisements would be reckless. Instead, advanced civilizations would seek to blend into their environment. Their energy use would be tightly controlled. Waste heat would be minimized or radiated in ways indistinguishable from natural processes. Large-scale engineering would be concealed beneath planetary surfaces or distributed in diffuse, unremarkable forms. From afar, their systems would appear quiet, ordinary, and uninhabited. This possibility forces a re-evaluation of how we search for life. Our instruments are designed to detect excess, anomaly, brightness, and noise. We look for signals that stand out against nature. But if survival selects for invisibility, then the most successful civilizations will be those least likely to be detected by our methods. We may be searching for the wrong thing entirely. Even the search for biosignatures, chemical markers of life in planetary atmospheres, may be affected by this logic. A sufficiently advanced civilization might deliberately regulate its atmosphere to avoid producing obvious signs of biological activity. Industrial gases, free oxygen, or other detectable markers could be managed or masked. Life would still exist, but it would be quiet, subtle, hidden behind layers of intentional control. This does not require malice or paranoia. It requires only patience. A civilization that expects to exist for millions of years must think in terms of risks that unfold over equally long spans. A single detection event, even if unlikely, becomes unacceptable when multiplied across geological time. Silence becomes the default not because danger is constant, but because it is irreversible. At this point, the dark forest begins to resemble an evolutionary process acting on civilizations themselves. Just as biological evolution selects the traits that enhance survival within an environment, the cosmic environment selects the behavioral strategies that minimize existential risk. Loud civilizations disappear. Quiet ones persist. Over time, the population of civilizations becomes dominated by those that are effectively invisible. This selection does not require coordination or agreement. No galactic law needs to exist. No shared ethics or treaties are necessary. The outcome emerges naturally from independent decisions made under the same constraints. Every civilization, regardless of its biology or psychology, faces the same uncertainty. Everyone must decide whether the potential benefits of being seen outweigh the risk of being noticed. Those that decide incorrectly do not get a second chance. Seen this way, the dark forest is not a theory about hostility. It is a theory about asymmetry, the asymmetry between knowledge and ignorance, between detection and response, between the speed of light and the speed of decision. A civilization can be detected instantly, but responding to that detection may take centuries. In that delay, outcomes are already set. This also explains why intentional interstellar messaging is so controversial among scientists. Even without assuming hostile aliens, the act of transmitting detailed information into the galaxy carries irreversible consequences. Once sent, a signal cannot be recalled. It cannot be clarified. It cannot be defended. It becomes a permanent record of location, capability, and intent, frozen in time and broadcast to anyone capable of listening. The famous transmissions humanity has sent so far were born of optimism, not strategy. They assumed that intelligence would recognize intelligence and respond in kind. They assumed shared curiosity and goodwill. The dark forest framework challenges those assumptions without invoking villains. It suggests that goodwill may be irrelevant in an environment where survival depends on caution rather than trust. If another civilization detected one of our messages, it would not need to respond to gain value from it. The message itself would already provide data, our level of mathematics, our understanding of chemistry, our biological structure, our approximate location, our technological stage. Even silence in response would be a rational choice. Silence preserves safety. Response creates vulnerability. This realization casts the search for extraterrestrial intelligence in a different light. The absence of replies may not indicate indifference. It may indicate competence. A civilization capable of detecting us and understanding the implications of contact would also be capable of understanding the risks of responding. Silence becomes not ignorance, but restraint. As observational technology improves, humanity will continue to find planets that resemble Earth more closely. Some may show tantalizing hints of biology. Others may appear strangely stable, their atmospheres regulated in ways that resist natural explanation. Interpreting these findings will require care. The absence of obvious life does not imply the absence of intelligence. It may imply intelligence that has learned how to remain unseen. The dark forest does not promise certainty. It offers coherence. It explains the silence without requiring rare miracles or universal self-destruction. It aligns with known physics, known limitations of communication, and known evolutionary principles. It does not claim that all civilizations are hostile. It claims that none can afford to assume safety. At this stage, the question shifts. It is no longer simply, where is everyone? It becomes something more personal and more urgent. What phase are we in? Are we still in the brief, dangerous window where a civilization is loud enough to be noticed but not wise enough to hide? Or are we already beginning the slow transition into quiet maturity? The answer is not yet clear. Humanity is still learning how visible it is, still debating whether reaching outward is a risk or a responsibility, still caught between curiosity and caution. The dark forest theory does not tell us what to choose. It only shows us the cost of choosing wrongly. When unequal civilizations have met on Earth, the outcome has followed a grimly consistent pattern. The difference in scale is smaller, the distance is shorter, but the logic remains the same. When one group possesses superior technology, organization, or energy control, the encounter does not resolve into mutual exchange. It resolves into dominance. History does not record many exceptions. Curiosity may initiate contact, but power determines the result. Across continents and centuries, technologically advanced societies have encountered others who were unaware of their existence moments before first contact. The imbalance was decisive. Those with greater reach reshaped the environment, the economy, the culture, and often the biology of those they encountered. Disease spread faster than understanding. Resource extraction outpaced adaptation. Even when intentions were mixed or benevolent by the standards of the aggressor, the outcome for the less advanced was often collapse. Entire ways of life vanished within generations. Languages disappeared. Knowledge was lost. The dominant civilization wrote the record that survived. What matters here is not morality, but structure. Contact between unequal systems creates irreversible change. The weaker side does not get to choose the terms. Even restraint can be destructive. Even curiosity can erase. The imbalance itself is the danger. Scaled up to the cosmos, this asymmetry becomes absolute. Any civilization capable of detecting another across interstellar distances must, by definition, possess superior technology. It must command greater energy, deeper time horizons, and more refined control over matter and information. To the detected civilization, the observer would be unknowable. To the observer, the detected civilization would be transparent. Its atmosphere, emissions, orbital mechanics, and technological signatures would reveal its stage of development with unsettling clarity. In such a situation, trust is not merely fragile. It is meaningless. The weaker civilization cannot meaningfully evaluate the intentions of the stronger, and the stronger has no incentive to reveal its own. Communication does not level this imbalance. It exposes it. The very act of responding confirms vulnerability. Silence preserves ambiguity. This is why the dark forest theory does not require aggression to function. It requires only asymmetry and uncertainty. A civilization does not need to intend harm to cause it. It only needs to exist at a higher level of capability. The mere act of noticing another civilization places the observer in a position of power. What follows depends not on ethics alone, but on risk tolerance. On Earth, risk tolerance has rarely favored restraint when resources or security were perceived to be at stake. The same incentives apply on a cosmic scale, magnified by time and distance. A civilization that chooses to eliminate a potential future threat does not need to act out of hatred. It only needs to act out of caution. The action may be cold, distant, and silent, but its effect would be final. This perspective reshapes how first contact should be imagined. Popular culture often portrays it as a meeting, an exchange, a conversation. In reality, it would more likely resemble observation without consent, assessment without dialogue, decisions made long before the observed civilization becomes aware it has been noticed at all. If humanity were detected tomorrow, we would not know. There would be no announcement, no message, no warning. Detection does not require interaction. It requires only listening. A civilization capable of long-term survival in the dark forest would not reveal itself by responding. It would continue to observe, waiting to see whether the newly detected species learns to quiet itself or continues to advertise its presence. This introduces a chilling possibility. The silence we experience may not be mutual. We may not be listening into emptiness. We may be the ones being listened to. Our own technological development already reflects a growing awareness of asymmetry. Surveillance technologies, remote sensing, and automated analysis allow observation without exposure. We value invisibility in military and strategic contexts. We recognize that being seen first is a disadvantage. These instincts did not emerge by accident. They are shaped by competition and uncertainty. The dark forest simply extends this logic beyond our planet. It suggests that any intelligence capable of long-term planning will eventually converge on the same conclusion. Do not reveal more than necessary. Do not assume goodwill. Do not trade safety for curiosity. This convergence would happen independently across civilizations. No coordination is required. No shared culture. No universal law. The environment itself enforces the rule. Those who ignore it do not persist long enough to shape the future. Those who obey it become the future, quiet and unseen. This also reframes the idea of exploration. Expansion is no longer a sign of success. It becomes a liability. Spreading across space increases the number of points at which a civilization can be detected. Each outpost, each colony, each energy source becomes another potential signal. A civilization optimized for survival would instead limit its footprint. It would grow inward, not outward. It would invest in resilience, efficiency, and concealment rather than scale. Over long timescales, this leads to a galaxy that appears empty but is not. It is full of civilizations that have chosen to occupy minimal volume, to reduce emissions, to erase traces of their activity as much as possible. Their presence is not announced by light or radio waves, but by absence, by the lack of anomalies, by systems that look perfectly natural because that is the safest appearance to have. This does not mean that conflict never occurs. It means that conflict is rare and decisive. When it happens, it leaves little evidence. A sterilized planet does not broadcast its history. A removed civilization leaves no ruins visible across light years. Over time, even the memory of such events fades into the background of natural cosmic evolution. From our perspective, this makes the universe appear serene. Stars burn, galaxies rotate, nebulae glow. Everything seems governed by slow, impersonal processes. But beneath that calm may lie the accumulated outcome of countless decisions made by intelligent beings choosing silence over exposure. At this stage, the dark forest theory ceases to be about aliens. It becomes about strategy. It asks what behavior persists under extreme uncertainty and irreversible risk. And it offers an answer that is deeply uncomfortable for a species driven by curiosity. Survival favors those who resist the urge to announce themselves. Humanity is still early in this process. We have only just begun to recognize how detectable we are. We have not yet fully decided whether exploration or restraint will define our future. The choices we make in the coming centuries will determine whether we remain a brief flare in the dark or learn how to exist quietly for the long term. The forest does not punish curiosity immediately. It allows it briefly, long enough for a civilization to reveal itself. And then, if the lesson is not learned, the forest grows quiet again. Beyond asymmetry and fear lies an even quieter force that shapes behavior in the dark forest. Time. Not just the passage of years, but the vast difference between biological timescales and cosmic ones. Civilizations think in generations. Galaxies evolve over billions of years. Any intelligence that survives long enough to understand this difference must adapt its priorities accordingly. Short-term gains become irrelevant. Long-term persistence becomes everything. From this perspective, patience becomes the most powerful trait a civilization can possess. Waiting costs little. Acting prematurely costs everything. A civilization that remains silent loses nothing but curiosity. A civilization that reveals itself risks extinction. Over enough time, the calculus becomes unavoidable. Silence is cheap. Exposure is irreversible. This is why the dark forest does not require constant vigilance or aggression. It requires endurance. A civilization does not need to hunt others actively. It only needs to be prepared for the possibility that others may one day become threats. Observation replaces confrontation. Monitoring replaces messaging. Intelligence gathering replaces diplomacy. The galaxy becomes a place where knowing is safer than speaking. Over millions of years, this creates a layered environment. Young civilizations emerge, unaware of the rules. They experiment. They broadcast. They expand. Older civilizations notice them long before they notice anyone else. Some young civilizations fade on their own, undone by internal pressures. Others persist long enough to be evaluated. The critical question is not whether they are peaceful now, but whether they could become dangerous later. This logic may feel unfair, but fairness has no role in survival. A civilization capable of altering planets, manipulating energy on large scales, or expanding beyond its home system represents uncertainty. Even a peaceful species today could evolve into something else tomorrow. Biological evolution, cultural shifts, and technological acceleration ensure that intent is not stable. A distant observer cannot gamble on the future character of another intelligence when the cost of being wrong is annihilation. Because of this, the dark forest encourages preemptive thinking without requiring malice. Removing a potential threat before it matures is safer than negotiating with it later. Waiting for certainty is not an option, because certainty never arrives across interstellar distances. By the time intent becomes clear, action may already be impossible. This idea unsettles because it strips away the comforting notion that advanced intelligence naturally leads to wisdom or cooperation. Intelligence increases capability. It does not guarantee benevolence. In fact, it increases the consequences of error. The smarter a civilization becomes, the more catastrophic its mistakes can be. From a survival standpoint, assuming goodwill is irrational. The silence of the universe may therefore reflect not peace, but discipline. A collective outcome shaped by countless independent decisions to avoid irreversible risk. No civilization announces itself because none can justify doing so. Not because all are hostile, but because all are constrained by the same logic. This raises an unsettling mirror for humanity. We often imagine ourselves as observers searching an empty sky. But from another perspective, we may already be part of the pattern. Our early broadcasts were unintentional, the byproduct of inefficient technology. That phase is passing. As our systems grow more efficient, our detectability decreases. Our planet becomes quieter. Our emissions more controlled. Without ever naming the dark forest, we are behaving as though it exists. At the same time, our instruments grow more sensitive. We watch more carefully. We analyze atmospheres, star systems, and anomalies. We listen far more than we speak. This asymmetry between observation and transmission mirrors the behavior predicted by the theory. Whether by instinct or reason, we are moving toward the same equilibrium. If the dark forest is real, then the most important transition a civilization makes is not technological, but behavioral. The moment it realizes that being seen carries risk. The moment curiosity must be balanced against caution. The moment exploration becomes a question not of capability, but of wisdom. This does not mean that the universe is doomed to eternal silence. It means that communication, if it ever occurs, will be rare and carefully chosen. It will not be casual. It will not be broadcast. It may take forms we do not yet recognize. Subtle, indirect, ambiguous signals designed to test without revealing. Even then, contact would be slow, cautious, and limited. It also means that many civilizations may choose paths that remove them from physical space altogether. Digital existence, simulated environments, or inward-focused societies reduce the need for expansion and exposure. A civilization that no longer depends on physical territory or visible energy use becomes nearly impossible to detect. To an external observer, it simply vanishes, not through destruction, but through withdrawal. From the outside, such a galaxy looks empty. From the inside, it may be crowded with minds that have learned to coexist without announcing themselves. The silence becomes not a failure of communication, but a sign of maturity. As humanity continues to explore, the question is not whether others exist, but whether we are prepared to accept the implications if they do. The dark forest theory does not ask us to be afraid. It asks us to be cautious. It suggests that survival in a universe governed by uncertainty favors restraint over revelation. We are still early. Our noise has only traveled a short distance compared to the size of the galaxy. Our technological adolescence may yet pass without consequence. But the window will not remain open forever. Each advance brings both capability and visibility. Each choice shapes how we are perceived, if we are perceived at all. The forest does not rush. It waits. And in that waiting, it allows civilizations to reveal who they are, not through what they say, but through whether they learn when to remain silent. The final implication of the dark forest is not despair. It is responsibility. If intelligence is rare and fragile, then survival itself becomes meaningful. To exist quietly, to endure without erasing others, may be the highest achievement a civilization can reach. The universe may not reward those who shout the loudest. It may reward those who learn how to listen, how to wait, and how to remain unseen beneath the stars. The final consequence of the dark forest is not annihilation, but restraint. A universe shaped by this logic does not collapse into chaos. It settles into stillness. Over immense spans of time, the same conclusion is reached again and again by independent minds, separated by light years and evolution itself. Survival favors those who reduce uncertainty. And the greatest uncertainty is being known. This transforms the meaning of intelligence on a cosmic scale. Intelligence is no longer defined by expansion, dominance, or visibility. It is defined by self-control, the ability to restrain one's own power, the ability to resist the instinct to announce existence simply because it is possible, the ability to accept isolation as the price of longevity. From this perspective, the universe is not hostile. It is unforgiving. It does not punish curiosity directly. It punishes recklessness. It does not reward silence out of kindness. It rewards silence because silence reduces risk. The galaxy becomes a place where civilizations that endure are not those that conquer, but those that choose not to be seen. This reframes the great silence one final time. What we call emptiness may be the most stable arrangement intelligence can reach. A delicate equilibrium where countless civilizations coexist without contact, without conflict, without acknowledgement, each aware of the possibility of others, none willing to take the irreversible step of revealing themselves. It is tempting to imagine this as tragic, a universe full of minds that never meet. But from another angle, it is a form of peace. Not the peace of friendship or cooperation, but the peace of non-interference. A silence maintained not by agreement, but by shared understanding of the stakes. For humanity, This interpretation carries weight. We stand at the threshold where our actions begin to matter on a cosmic scale. Our technology grants us the ability to be noticed. Our curiosity urges us to reach outward. Our caution urges us to slow down. The dark forest theory does not command us to hide. It warns us that being seen is a choice with consequences that unfold over thousands or millions of years. Every signal sent into space is permanent. Every transmission carries more information than intended. Every attempt at contact is also an act of exposure. Once made, it cannot be undone. The universe does not offer second chances to civilizations that reveal themselves too soon. And yet, there is something profoundly human about the desire to speak anyway, to announce existence, to hope that the unknown is kind, to believe that intelligence might recognize itself and choose cooperation over fear. That hope has driven exploration, science, and progress on our own world. Without it, humanity would not exist as it does. The dark forest does not say that hope is wrong. It says that hope must contend with reality. It asks whether courage lies in calling out or in enduring quietly, whether the highest expression of intelligence is contact or survival. Perhaps the answer lies not in extremes, not in shouting into the void, nor in retreating entirely, but in patience, in learning, in understanding the environment before acting within it. A forest at night does not demand silence forever. It demands awareness. A traveler who listens first may live long enough to choose when to speak. If one day the silence breaks, it will not be sudden or loud. It will not arrive as a broadcast echoing across the stars. It will come carefully, indirectly, and ambiguously. A signal that reveals little. A test rather than a greeting. A whisper rather than a shout. Because any civilization that has survived long enough to speak will have learned the same lesson. Until then, the universe remains quiet, not because it is empty, but because intelligence, when it understands the cost of being heard, learns how to wait. The dark forest is not a story about monsters hiding between the stars. It is a story about restraint written across the largest canvas imaginable. A reminder that in a universe governed by uncertainty, the most powerful act may not be to announce existence, but to preserve it. And so, the stars shine. The galaxies turn. The silence holds. Not as absence, but as choice.